Hello, good day. This is Sir Hanif. Assalamu alaikum wa rahmatullahi wa barakatuh. And today we will be continuing our discussion for our subject here in ES 211. Okay, so last meeting I have discussed the series RL and RC circuit. Okay, so supposedly, this would be the week 7 and 8 topics that we have to discuss. So I have mistakenly discussed, no, or introduced to you the previous topics. So supposedly that would be the week 10 and week 11, week 9 and week 10 topics. Okay, so anyway, I will just change it no na lang doon sa post natin. So we will be changing that one to week 9 to 10. Okay? So today we will be discussing the week 7 and week 8 topics, no, which is the capacitor and inductor. So this would be the preliminary topics that would be tackled about in or that would be concerned about the capacitor and inductors. Okay? So as you can see here, we will be tackling about here the capacitor and inductors, na, which is supposedly to be used, okay, in our discussion last meeting. Okay, so yun nga, I mistakenly introduced to you the topic that should be discussed on week 9 and 10 coverage. Okay, so in here we will be having this capacitor inductors. Okay, so what are the characteristic and uses of these um, uses of these circuit element? Okay, so we have here the capacitor. A capacitor is consist of conducting plates separated by inductor by insulators or dielectric. So usually that dielectric is either a air or a dielectric material. Okay, so usually they uses air to have that one. It's because it has a multi-purpose applications. So we have here the capacitance is the ratio of charge on plate of capacitors or to the voltage difference between the two plates measured in farad. So this would be the equation, no? So ito, this is the general equations. Okay, so the capacitance in terms of the electric constant and the area of the plate and its distance is using these equations. Okay, as given by these equations, we have here the capacitance is the ratio of the charge on the plate of the capacitor or the voltage difference. Okay, so this is just the reciprocal of this definition here. Okay, so generally speaking, if you have capacitance, we have these equations to represent that one. Okay, and in symbol, this would be the symbol used in order to represent the capacitance. Okay, so we have here the current is given by, as we have already defined this one. Okay, so we have here I is equals to dq over dt. So by using that one in representing the definition of capacitance, we have here I is equals to c dv over dt. Okay, so by integrating that one, no, we can actually find the value of a voltage, no. So we have here voltage is equals to 1 over c integrating of I, the expression of this I, dt plus v at time t is equals to 0, means that this would be the initial value of voltage evaluated from t sub o to t. So we have here the voltage, no? Then if you are asked to find the value of powers, we have just the multiplication of voltage and current. So we have here C is equals to V dV over dt. Okay? Now, so then the energy is given by these equations, the integral of power dt. Then if you take the integral of this power here, uh, you would uh, you would have these equations. We have W is equals to, or energy is equals to 1/2 CV squared. Okay, or in terms of representing these equations in terms of q and capacitance, we have this equation. So okay, so we have here a capacitor is an open circuit to DC, no, pakitandaan lang to siya, no. It is very important, it is very important kasi magagamit natin to siya doon sa actually nagamit na natin to siya doon sa calculation natin sa RC and RL, di ba? If you would imagine, if the capacitor, no, when we was the when we introduce the series RL and RC, if that capacitor have reached its maximum value of charge, no, it would be have like a DC, open circuit na, no, okay. So so and then the voltage on the capacitor cannot change abruptly. So this is also very important, no? So ibig sabihin nun, the capacitor, no, if you suddenly disconnect the source that is being connected to a capacitor, it would not change abruptly. So ibig sabihin, constant yung kanyang value. Okay, and or ibig sabihin nun is that hindi siya suddenly magbabago yung kanyang value. So which is nagamit na natin din natin yun siya sa previous natin na discussion. So example number one, we have here calculate the charge stored on 3 picofarad capacitor with 20 volt across it. So and letter B, find the energy stored in this capacitor. So you just have to use the equations that we have already stated on our previous discussion. So okay, so just read this one. So we have here the practice problem, same as this equation, same as this problem here. So please answer this one also. So example number two, we have here the voltage across 5 microfarad capacitor is given by this equation. We have 10 cosine of 6,000 t volt. Then calculate the current through it. So if you have this equation, then you ask to find the value of current. You will just have to use this equation to find the value of current. No? So uh, by using these equations, we have uh, capacitor, the value of capacitor multiplied by the derivative of the voltage given. Okay, so if you derive the value of this voltage here, you would have this equation, no? So therefore, the value is negative 0.3 sine of 6,000 t ampere. Okay, so example number three, so we have here determine the voltage across 2 microfarad capacitor if the current through it is this one. Okay, then assume that initial capacitor voltage is zero. Okay, so you are given this equation of current, then you ask to find the value of expression of voltage. So ibig sabihin, you have to use this integration of I with respect to time. Okay, then take note here that given that the initial voltage daw at capacitor is zero, so ibig sabihin this V sub O here is equal to zero. Okay, so as it's being stated here. Now, substitute the value of current here sa integral, sa loob ng integral, then integrate natin yun siya, so you would have this value. Okay, so yun. So we have here the practice problem, so kindly answer this one. Okay, so we have here example number 5. We have obtained the energy stored in each capacitor under DC condition. So yun nga, no, as I have said kanina, if if the capacitor is uh, have already connected on a source for a long time, it would be have like a open circuited, no? So, ibig sabihin nun, if this is in a condition of a DC conditions, we have this open circuited. So, ibig sabihin, wala na to. Then, wala na rin. Ito siya is also open circuited. So, we could actually neglect this 5 kilo ohm here since this is neglected itong uh, microfarad dito. Okay, yung capacitor natin dito. So, we have here, obtain the stored energy in each capacitor under DC condition. Okay, so yun. Yun. So as we can see here, these are being open circuited, no? Then finding the value of V1 and V2 here, since we can use that one in order to find the value of energy. Okay, so we have here I is equals to 3 over 3 plus 2 plus 4. Saan to nanggaling? So this is from current division. Okay, bakit? Kasi nga if this 6 milli if this capacitor here as is open circuited, so ang branch lang natin is ito lang, ito at saka ito. Okay, so ibig sabihin yung 6 milliampere is nadi-divide dito sa 2 plus 4 kilo ohm, and then dito sa 3 kilo ohm dito. Okay, so performing the current division here, so we have this formula. Okay, so 3 kilo ohm over the sum of all resistance except this 5 kilo ohm kasi nawala naman yun siya, no? Kasi nga open circuited dito, so wala nang dumadaan na current dito, so neglected na din itong 5 kilo ohm natin. Okay, so we have here the V1 value of V1, we have this one, and then the value of V2 we have also this one. And using the equation of energy of the capacitor, we have these equations, so we can now find the value of W1 and W2, or energy 1 and energy 2. Okay, so we have here the practice problem, so please solve this one, no? So madali lang naman to siya. So remember that if you assume the circuit is operated in DC, so we can assume that this is open circuited. Okay, so we have here series and parallel capacitor. So for series and parallel capacitor, uh, for parallel capacitor, in order to have the equivalent of that one, you just have to perform the uh, addition, no? So you just have to add this one if it is parallel. Okay, then if it is series naman, uh you just have to have the equivalent of this one, same as how you can get the equivalent of parallel resistor. Okay, so baliktad, no? Baliktad yung operation ng capacitor and resistance, take note of that. Okay, so we have here we have here this performation of equivalent of capacitor and inductor. Okay, so we have here the example of how to find the equivalent capacitance and capacitance of a certain connection of capacitor. So please read that one. Okay, so same as this one. So in a way, madali lang naman yun siya. So okay, so let me cut this video muna. So we will just continue mamaya. Okay.